simplify using trig identities. So here simplify means we're rewriting, essentially simplify this expression. We're not solving for unknown variable, we're just rewriting it to make it look simpler. So here we have to remember some of the identities. Cosine of negative of an input angle is same as cosine of the same angle but the positive value. So this right here, we can rewrite this as cosine of x. Secant, we rewrite it as 1 over cosine. And for sine right here, sine negative x, because sine is an odd function, is the same thing as negative sine of positive angle. Like this. So this one we can rewrite it as sine, negative sine, multiply negative sine x. So we see that this cosine cancels out. So only thing we have left is negative sine x. Let me put equal sign here. Simplify using the trig identities in terms of second expression. So we're going to simplify this expression, and the final answer should only have something in terms of sign. So it can be with sign, it can be sine square, number times sign, number divided by sign, just in terms of sign. Okay. So let's start here. We have cotangent. We can rewrite this. Cotangent is same as cosine x over sine x plus sine x over 1 plus cosine x. Now when we add a fraction, we need to have a common denominator. So if I want to combine these two fractions into one fraction here, we need to have a common denominator. So on the left side, I'm going to multiply this top and bottom. And on the right side, I'm going to multiply sine top and bottom. So let me write that. So here I'm going to multiply by, let me actually write the next line. So I have cosine x over sine x, leave some space, plus sine x over 1 plus cosine x. I'm going to multiply here 1 plus sine x in parentheses over 1 plus sine x parentheses. Now this right here is same thing as multiplying 1. So we're not changing the quantity of the expression. Okay, so we're multiplying 1. So we're only making it look different. And here I'm going to multiply by sine x over sine x. Okay. Oops, I'm sorry, I made a mistake. I meant to write 1 plus cosine x over 1 plus cosine x. Because we're multiplying this right here and right here. So we can have a common denominator. So now if you look at this, on the denominator for each fraction, this one has sine times 1 plus cosine x. This also has sine times 1 plus cosine x. So we have a common denominator. We have a same denominator. So here, I'm going to write only sine x times 1 plus cosine x once, common denominator. So in the numerator, I have cosine x times 1 plus cosine x plus sine square x. Like this. This is sine times sine is sine square. So equals, now we can distribute this cosine right here. Then I have cosine x plus cosine square x plus sine square x over sine x 1 plus cosine x. So here we have to remember, this is one of the identities you have to remember, where it's cosine square x plus sine square x equals 1. So let me write that. This is one of those things you have to remember. Sine square theta, whatever the angle is, same angle, cosine square theta equals 1. So then that's what we have here. So this entire thing is 1. So when we simplify on the right side, we have cosine x plus 1 over sine x times 1 plus cosine x. Now if you look at here, 1 plus cosine x, right? And 1 plus cosine x are same. Well, cosine x plus 1 is same as 1 plus cosine x. Right? These two are same. So these two cancel out. So we have left with only 1 over sine x. So this is the final answer when we're able to write in terms of sine. So not in terms of sine is not saying that exactly equal sine, but the expression in terms of sine using sine x. Verify that tangent square x over tangent square x plus 1 equals sine square x. So here we're verifying. We're verifying that this expression is indeed equal to this one. So when we do this kind of problem, again, we're not solving for anything. We're not solving for a known variable. We're just showing or verifying the left equals right. Left expression equals right expression. And when we do this kind of problem, we want to start with the expression that looks more complicated and try to simplify this to sine square x. Okay? So here, there's several ways to, well, there's at least two ways to do it, but let's look at the simpler one, where here we have to remember one of those identities. This is also called Pythagorean identity. 1 plus tangent square theta equals secant square theta. So we have to remember that. So instead of this right here, I can rewrite this as tangent square over secant square x by the trig Pythagorean identity. And here we don't want to write equal sine square. We don't know that yet. So equal and try to simplify more. What is tangent? Tangent is sine over cosine, sine x over cosine. Since it's a square, we have sine square x over cosine square x. The entire thing over, secant square is same as 1 over cosine square x. Then we have sine square x over cosine square x. And dividing a fraction is the same thing as multiplying the reciprocal. So we multiply reciprocal, cosine square x over 1. And as you can see, these two cancel out. So final answer, we simplified to sine square x. So as I simplify, I just naturally want to simplify it is equal to this. So we verify this is true. And for these problems, feel free to try more. Once if your first attempt doesn't work, just try the problem again. Verify that this expression equals this. So tangent x times sine x plus cosine x equals secant x. So when we're verifying, we're not solving for an unknown variable. We're just verifying the left expression equals right expression. So rewrite. So let's rewrite this. We know tangent is same as sine x over cosine x times sine x plus cosine x. Again, we usually start with the more complicated side and try to simplify the more complicated to the simpler side. So let's move on. So here we can do sine times sine. So we have sine square over cosine x plus cosine x. Now, how can we add this? In order to add this fraction and non-fraction, well, when we add fraction, and we can think this as actually cosine over 1. Right? Same thing, cosine x over 1 is same as cosine. And when we add two fractions, we need a common denominator. So since denominator is cosine x here, I can multiply cosine x over cosine x here so that we have a common denominator. So we have sine square x. This right here gives us cosine square x. And we have a common denominator. We have a common denominator of cosine. This one has sine square x over cosine. This has cosine times cosine over cosine x. So both have denominator of cosine, like this. So then we have to remember this is one of the Pythagorean identity. So this equals 1, right? So this right here is 1 by the Pythagorean identity. Well, that doesn't look like 1, so right. This equals 1. So we have 1 over cosine x, which is same thing as secant x, right here. So we verify that left and right are equal. Find the exact value of sine 75 degree. So when we look at this, when we find the exact value, if you can find this directly from the unit circle, we're done. Okay, but here we know that sine 75 degree is not on unit circle, not given from the unit circle. So this is how we know we have to do something else. Okay? So what we do is we try to break this angle, 75 degree, into two angles that are on the unit circle. So we can use the unit circle values. So we can either find two angles that we add to get 75, or we get two angles that we subtract to get 75. But here we can actually separate into 30 and 45 degree. Okay. So here we can rewrite sine of 75 degree equals sine of 30 degree plus 45 degree. And we use sum and difference formula, sum and difference identity from the identity sheet. So it tells us that sine of angle A plus B is same thing as sine. Let me actually write these first and I'll fill in the angle in a second. So this is from the formula for sum and difference identity. This is sine. So the first angle goes to here. 30 degree, 30 degree. And the second angle goes here and here. 45, 45. And we know now we can find each of these from the unit circle. Okay? So we find sine 30 degree, sine 45 degree, cosine 45, cosine 30, all from the unit circle. So let's write one at a time. So equals sine 30 degree from the unit circle, right, is half. So we have half times cosine of 45 is square root 2 over 2 plus cosine of 30 degree is square root 3 over 2 times sine 45 is square root 2 over 2. So we can simplify in the next line. When we multiply fractions, we multiply bottoms together. So 2 times 2 gives us 4. This is just square root 2. So we have square root 2 over 4 square root 2 over 4 plus, here we have square root 3 times square root 2 is square root 6 over 4. 2 times 2 is 4. Square 6 over 4. And we can, since we have a common denominator of 4, we can write in one fraction, square root 2 plus square 6 over 4. And this is as simple as we can simplify. We cannot write this as square root of 8. Right? Square root doesn't work that way. So this is as simple as we can write it here. So remember, 75 degrees is not on the unit circle. So we find two angles that is on the unit circle. So we can apply sum and difference formula, and we can find each of these from the unit circle. Given cosine theta equals negative 12 over 13, and theta is in the third quadrant, find sine 2 theta. Here, first we have to pay attention here. We're looking for sine 2 theta, not just sine theta. Okay? So since it's sine 2 theta, we have to use double angle identity. Double angle identity tells us that sine 2 theta equals 2 times sine theta times cosine theta. So in order to find sine 2 theta, we have to know sine theta and cosine theta. This is not just like 2 times sine theta. We have to use this identity. And cosine theta is already given. That means we have to find what sine theta is using this information and this right here. So first, we want to draw the theta. So let's draw theta. So theta is the third quadrant right here. So this third quadrant is right here, right? This is first quadrant, second quadrant, third quadrant. So the angle is somewhere here, right here. And it says cosine theta is negative 12 over 13. So we can write it like this because we usually consider radius as 13. And we know that cosine value represents horizontal distance, right here, this distance or this distance is either same, but let's write it here. This is negative 12 because in the left side of y-axis, it should be negative 12. But then we need to find now sine theta, which means we need this distance. We find this distance and we divide the distance divided by 13, the radius length or hypotenuse of a right triangle. So in order to find the distance, we need a Pythagorean theorem. We know that 13 square equals negative 12 square plus, let's call this h square. This is 169 equals 144 plus h squared. Subtract 144 both sides. I get 25 equal h squared. So then h can either be positive 5 or negative 5. So we have to see, looking at the location of angle, which one would be. Here it has to be negative because h is right here, right below the x-axis. So this must be negative 5, not positive 5. Okay. So now that we know the length, we can also find sine theta here, which is negative 5 over 13. So now we know both of these. We can use both of these and plug it right here to find sine 2 theta. So then let's continue here. Sine 2 theta equals 2 times sine theta, entire sine theta is negative 5 over 13. Cosine theta is negative 12 over 13. Remember this entire thing right here. Sine theta is negative 5 over 13. We're not plugging in negative 5 over 13 to sine. Sine of theta gives us this value. Same thing, cosine of this value, cosine of theta gives us this value. So then we just multiply, we multiply this negative 5 times negative 12 gives us positive 60. So top is actually 120. Over bottom is 13 times 13, give us 169. So this is the answer, sine 2 theta. So every time we see sine 2 theta, cosine 2 theta, or tangent 2 theta, we should see if we need to use double angle identity because this is double the angle. Solve sine x equals negative sine square x. So in this case, we're solving. So we're solving for a unknown variable. In this case, we're finding an angle x such that makes this equation true. So what we can do is first we want to have a 0 on the right side. So in this case, we do not divide both sides by sine, because sine could be 0, and we cannot divide by 0, right? So what we do is we add sine square x both sides. So we have sine x plus sine square x. We cannot divide by sine x here, because sine can be 0. Okay, so this is the only way. Add equals, and the right side will be 0. So then what we can do is, again, the sine square is this is the same as sine times sine. So we can factor sine out. Each term has at least one sine, so I can factor sine x, parentheses, and I have 1 plus sine x equals 0. So all I did is factor sine. You can check, if I multiply sine to 1, I get sine back, right? Also, if I multiply sine to sine, I get sine square if I distribute back. So we can always check our factoring. Okay? So then, in order for this equation to be 0, either sine has to be 0, sine x has to be 0, or 1 plus sine x to be 0. So here we have two equations. This separates the two equations. Sine x equals 0. Well, let me actually match the color. Sine x equals 0. Or 1 plus sine x has to be 0. Because either if this is 0, 0 times whatever is 0. Also, if this is 0, 0 times sine x will give us 0. So then we look at the unit circle, which angle on unit circle such that sine of that angle is 0. Okay. So in unit circle, angles are pi over 2 and 3 pi over 2. Okay, so this equation is give us this at the moment. And let's solve. So then let's solve this one. We can subtract 1 both sides. So then we look at unit circle, which angle on unit circle gives us sine of that angle, -1. Okay. Oh, I'm sorry, I confused with the cosine. I was thinking in my head. Sine 0, sine is the y coordinate on the unit circle, right? So this is actually 0 and pi. Angle 0 and pi. Okay. And here sine is -1. What angle is that? The angle on unit circle that sine gives us -1 is 3 pi over 2. That's the only one on the unit circle. Okay. So if you only look at unit circle, which give us angle only between 0 and 2 pi, this 3 will be the answer. But this one doesn't give us any restriction, right? So actually our answer is not done yet. So our answer so far is 0, pi, and 3 pi over 2. But to each of the angle, each angle has infinite number of coterminal angle. So we can add 2 pi times k. K is just integer, like 0, -1, +1, +2, +3, -1, -2, -3. K is just an integer. So here essentially what we're doing is we're adding or subtracting any number of a full rotation. Okay, here also add 2 pi k, add 2 pi k. So essentially we have infinite number of answers for this problem, but we don't just say infinite number of answers because we can find the form. Each answer has form of 0 plus 2 pi k, pi plus 2 pi k, 3 pi over 2 plus 2 pi k. So all the infinite number of answers we have is coterminal to 0 radian, pi radian, 3 pi over 2 radian. So these three expressions are answer to this equation. Any of these angles will make this equation true. So when the restriction is not given, we always have to add 2 pi k to each of the answer we find on the unit circle. Solve 2 cosine square x minus 5 cosine x minus 3 equals 0. So here, again, we're looking for an angle such that make this equation true. So for a problem like this, what we do is we can set cosine of x. Let cosine of x be a, capital A. So we can replace a here, and I'll explain why we do that. We have 2a squared, because cosine squared, minus 5a minus 3 equals 0. The reason we replace it with a is because now it is easier for us to see if we can factor this. So this is in fact factorable like this. This is quadratic. We have 2a, a. Right? So let's see. If we have plus 1 and minus 3, let's give us negative 6a and 1a. And 1 times negative 3 is negative. So if this is a factor form of 2a squared minus 5a minus 3. The reason we do that is because it's easier to factor when we replace. So then we solve either this equal to 0 or this equal to 0. So we have 2a plus 1 equals 0 for one of the equation, and a minus 3 equal to 0 for one of the equation. So let's solve for a for each of them. Isolate a. So a here is, we subtract 1 both sides and divide by 2. So we have negative 1 over 2. And here we have a equals 3. So once you come this far, then we put back what a was. A is cosine x. So cosine x equals negative half. Cosine x equals 3. So we have two equations. Let me write it here. Cosine x equals negative half. Cosine x equals 3. So we're finding for these angles that will make each of these equations true, which will make this equation true. So then we'll refer back to unit circle. What angle on unit circle, cosine of that angle gives us negative half. Cosine is x value, so here it gives us 2 pi over 3. Cosine of 2 pi over 3 gives us negative half, but also cosine of 4 pi over 3. Okay, so that's the two angles from unit circle from this equation. Now this equation tells us cosine x equals 3. Cosine x cannot be 3. Right? We know this because when we also graph cosine x, it does not go above 1. 1 is as big as it could be. Also from the unit circle, it tells us that the biggest cosine can be is 1. So this does not give us any answer, any solutions. So we still need to write it to verify that it doesn't give us any answer. But this part it doesn't contribute giving us answer here. Okay, so no answer from this. This is not possible. Cosine cannot equal 3. So only this part happened to only give us answer for this equation. So we're almost done. Here it does not give us any restrictions, right? So we have to add 2 pi k to show that we have infinite number of answers. Coterminal to this angle, coterminal to this angle, or answer to this equation. So this equation have two answers. Let me actually circle a different color. These two are the answers. So you must write 2 pi k when restrictions not given. X equals 1 for 0 and 2 pi, for the angle between 0 and 2 pi, essentially from the unit circle. So this equation would have finite number of answers because we're only looking at angles between 0 and 2 pi. So first, let's divide by 3 both sides, like this. So we have tangent square x equals 1 over 3. Then we take the square root both sides, like this. But then when we do that, we actually need to have plus minus for the right side. So tangent x equals plus minus square root of 1 over 3, which we can rewrite plus minus 1 square root of 1 over square root of 3. But square root of 1 is just 1, right? So we have plus minus 1 over square root of 3. So on unit circle, we need to find angles such that tangent of that angle is either plus or minus 1 over square root of 3 or negative 1 over square root of 3. And we could rationalize here by multiplying like this, which gives us plus minus square root of 3 over 3. Okay. Either way will help us find the same angle. So let me write, so we have 1 over square root of 3 or negative 1 over square root of 3. So we know that sine x over cosine x gives us tangent x, right? So on unit circle, for example, tangent of pi over 6, which is sine pi over 6 over cosine pi over 6, gives us sine pi over 6 1 over 2. This is square root 3 over 2, gives us 1 over square root 3. So pi over 6 is one of the answer. Okay. And similarly, 7 pi over 6 also gives us 1 over square root 3. And in terms of negative, it would be 5 pi over 6 from the unit circle, and also 11 pi over 6. So the four angles for this answer, this equation, is pi over 6, 7 pi over 6, 5 pi over 6, 11 pi over 6. We can actually write the angles in order of size. Pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So these four are the answers. Oops. 7 pi. This is just pi. So any of these angles will make this equation true. Solve sine square x plus 2 sine x minus 3 between angle 0 and 2 pi. So when we have a quadratic like this, we can try to factor. So let a be sine x. Then we get a squared plus 2a minus 3. Oops, actually I forgot to type 0 equals 0 here. So this should be equals 0. Okay. So then we can factor this a, let's see, minus 1, a plus 3 equals 0. So either this has to equal to 0 or this has to equal 0. A minus 1 equals 0. A plus 3 equals 0. So then a equals 1. A equals minus 3 or negative 3. Well, what is a? A is sine x. So then we can write sine x equals 1. Sine x equals negative 3. So this one is only asking between 0 and 2 pi. So we do not write 2 pi k. We should have finite number of answers. So what angle on unit circle such that sine of that angle equals 1? Well, it's pi over 2. Okay. And here, sine x cannot never be negative 3. Right? We can also know this by looking at sine graph. Sine graph goes as low as negative 1. It does not go below negative 1. I mean, of course, unless there's transformation. But sine graph itself, lowest it can be is negative 1. So this does not give us any answer. So we only have one answer for this problem, pi over 2. So for some problem like this, right, this replacing a, if you can do it right away, where you can factor a sine x minus 1 sine x plus 3 equals 0, then you do not need to do this a thing, right, this substitution thing. Because then we set this equal to 0, this equal to 0, right? So then we have sine x minus 1 equals 0, sine x plus 3 equals 0. Sine x is 1, sine x is negative 3, which is essentially the same thing as we got here, right? Oops. These two are same as here. So we have essentially two ways of doing it, and either way is fine, whichever you feel more comfortable. Okay. But sometimes we do want to write it this so that it is easier for us to see if we can factor or not. But if you can do this right away, totally fine. You can do this right away. It's up to you. Solve 2 cosine of x minus 3 minus 1 equals 0 for angle between 0 and 2 pi. So here we have x over 3, right? Don't worry about this at the moment. We're going to solve this problem just like if it were to be only 1x in the beginning. Then we'll worry about x minus 3 later. So for now, let's isolate this trig expression. So we have 2 cosine of x over 3. I'm going to add 1 both sides to have 1 here. And then I want this by itself, so I'm going to divide by 2 both sides, which gives me 1 over 2. So then, on the unit circle, again, angle must be between 0 and 2 pi. On the unit circle, we're going to find the angle such that cosine of that angle gives us half. Okay? Which is pi over 3, cosine of pi over 3, and cosine of, let's see, 5 pi over 3. 5 pi over, let me think. Yeah, 5 pi over 3. It will give us cosine of that angle, half. Okay. So that means that this x minus 3, this entire thing of x minus 3, x over 3 must be pi over 3. Entire thing of x over 3 must be 5 pi over 3. But we're solving for x. So if you want to solve for x here, just multiply 3 both sides, which gives us x equals pi. Okay. And we multiply also 3 here. X equals 5 pi. But answer must be between 2 pi, 0 and 2 pi, right? So this is not an answer. This is not part of answer because it's restriction, because of this restriction. So only answer for this problem is x equals pi. Again, we worry about this inside later after we isolate the trig expression. Until we can find the specific angle like we did here. We don't worry about it. Then we set it, we know this entire thing has to be either pi over 3 or 5 pi over 3. Then just solve for x by multiplying 3 both sides. So this is the only answer for this problem. So make sure to exclude this since 5 pi is greater than 2 pi.